Hello everyone, welcome to this next question on complex analysis. This question is from the year 2007 and it is of 2 marks. The question is, if f of z is given to be this function, then the coefficient of the term 1 divided by z cube in the Laurent series expansion of this function when the region is given to be modulus of z greater than 2. So you have something like this, modulus of z greater than 2. So we'll first see this region, modulus of z equal to 0. So that means we would have a circle centered at 0 and with having radius as 2, right? So this would be the circle. Pardon my drawing. So this would be the circle, right? So what would be the region? This region mod z greater than 2. So this region would be this part excluding this boundary, everything outside this circle. So this would be the region mod z greater than 2, right? So in this region we are to expand this function f of z in the Laurent series expansion. So this thing is really important for this question. So pay attention. So here this is the function. So this is a second order polynomial, right? So you could simplify this, factorize this very easily. So you'll be having the factors z minus 2 and z minus 1, and again you can apply the partial fractions onto this function. So you will be having this term. So that means when you simplify this, so you will be having z minus 2, z minus 1 and z minus 1 minus z plus 2. So this z and z cancels. So you will be left with 1 upon z minus 2 into z minus 1. So this is the partial fraction of this term. Alright. So after applying partial fraction, I have taken this z common from both the terms. So in the denominator. So it would be 1 upon z and you will be left with 1 divided by 1 from when you take z common. So here would be 1 minus 2 by z. So that is the thing. And again minus as such, 1 as such. When you take z common, so it would be 1 and then minus 1 by z. So you can rearrange this term and you can take this whole term to the numerator, taking its power as minus 1, and similarly with this term you can take its power as minus 1. So now we know 1 plus x raised to power n, this term, or in fact I should say 1 plus z raised to power n, this could be expanded into this series 1 plus nz plus n into n minus 1 into z square divided by 2, and then n into n minus 1 into n minus 2 divided by 3 into z cube, and so on, right? Whenever the modulus of z is less than 1. You can do this thing whenever the modulus is less than equal to 1. So this is the corresponding z. So in our case z is 2 upon z. Basically this term is 2 upon z. In fact with a minus sign. So our given region in the question, that is given to be modulus of z greater than 2. So obviously if the modulus is greater than 2, then it would also be greater than 1. So this thing is obvious from follows from this one. Now if modulus of z is greater than 2, you can shift this z to the right hand side. So you will be having 2 by modulus of z. So this thing should be less than 1. So basically we have divided by modulus z on both sides. So we obtained this thing, and similarly we have done for this term. So now 2 upon modulus z, this term is less than 1. So this term is comes out to be less than 1. So we can apply this relation onto this term, and similarly for this term. So when you apply this series term, when you apply this formula for this particular term, you will be having 1 plus the second term as such, and then the square of second term, and then the cube of second term, and so on, because it is minus 1. And similarly for the other term. So you will be having these two terms. So now you can very easily simplify this. 1 and 1 cancels. 2 upon z minus 1 upon z would be 1 upon z. 4 upon z square minus 1 by z square, that would be 3 by z square, and so terms like this, so on. So ultimately we'll be left with 1 upon z square plus 3 upon z cube plus terms with terms like this. Moving on, so it would be 8 upon z cube, and here it would be 1 upon z cube, so here it would be 7 upon z cube, right? So here it would be 7 upon z power 4 and terms like that. So this is the Laurent series expansion of the function. So now in the question they are asking what is the coefficient of the term 1 by z cube. So here the coefficient of the term 1 by z cube, that is 3. So our answer here is 3. So option C is the correct option. So I hope you understood this question. Well, that is it for this video. Thank you for watching.